If you would ask my mom what has been the most exciting moment in her life, she would definitely tell you that it was giving birth to my elder twin sisters here on my right. Exciting, isn't it? Celebrating life, celebrating our diversity as human beings and the different directions we take through the course of our lives. All of this starting from one single fertilized cell, then a tiny blob of cells transforming into a complex, multiple structure like you and me. And I'm sure many of you here would agree that this is one amazing journey to witness. Unfortunately, unlike this happy scenario here, many other families around the globe cannot share the same excitement due to a wide range of fertility problems or various health conditions. And even though in the past years we've made considerable progress in tackling these problems through in vitro fertilization, or shortly called IVF, the success rate of this procedure nowadays is still very low, typically below 30%. Not to mention the high costs involved or the massive disappointment experienced by couples going through these failures again and again. And one of the most critical steps during this IVF procedure is selecting the appropriate healthy embryo at the right development stage that can be implanted and lead to successful pregnancy. In my PhD thesis, I aim at dramatically improving the success rate of this procedure by developing devices and integrated sensors that can allow clinicians to determine the viability of healthy embryos and facilitate the selection of the embryos with the highest potential for a happy pregnancy. But how can I measure something that's 1 million times smaller than me, that tiny cell? Well, I can't shrink myself to that size, at least not yet. I can develop tiny functional sensors that can go down to the scale level and basically deploy them to babysit the development activity of embryos. By merging microengineering with chemistry and biology, I'm able to integrate non-invasive biosensors that can allow monitoring the biological activity of living embryos. And then I can establish molecular indicators that allow a thorough assessment of their selection. Is this a healthy embryo? Does this embryo show the right developmental competence? How we know that? In my thesis, I aim to predict these important questions by developing this biosensing technology. And I hope that in the years to come, many other families can enjoy this amazing celebration, this celebration of celebrating one of the most amazing things in this world that has to happen, life itself. Thank you very much.